Hi everyone. We're doing exercise 8.1 continuation, differentiating from the first principle. Suppose we have a curve. Say this is a curve, and the value of our curve is y is equal to f of x. It will be any function. And you need to find the gradient of the curve at a particular point. Say the point is A or the point is B. So the gradient of this curve at this point would be the derivative of this function. Derivative of this function, which could be y, can be written as dy by dx, or the derivative of the function f dash x. This is the normal way that we find the gradient of our curve by using calculus or by using derivative. However, there is a differentiating technique from the first principle where you can find the gradient of the curve without actually knowing the calculus. And the formula for it is f dash x, the gradient of the curve, is limit h tends to 0, f of x plus h minus f of x the whole divided by h. If you watch the previous videos, you know this is nothing but the gradient of your quad. Gradient of the chord. So the gradient of your curve is that as the chord, a point on the chord approaches zero, it will be equal to the gradient of the curve. So we find the derivative from the first principle, or we find the gradient of the curve using the first principle. We say that f dash x, that is my gradient of the curve at a given point, is limit h tends to 0 as that point approaches 0, f of x plus h minus f of x the whole divided by h. So you can find the gradient of the curve without using calculus from the first principle. Let's take it with an example. This is your example number 2 of your textbook. Point A has coordinates 4 and 16. So this is x and this is y. This point A lies on the curve with the equation y is equal to x square. At point A, the curve has gradient g. That means at point A, my dy by dx, or I would say my f dash x, is equal to g. Now I want to show that g is limit h tends to 0, 8 plus 8 x. That means I want to show that the derivative of this function is this using the first principle. So I know that the gradient of curve at first principle is equal to limit h tends to 0, f of x plus h minus f of x the whole divided by h. And at point A, my gradient is g. And I want to show that g is equal to this. So g is equal to limit h tends to 0. Now I'll write f. Instead of x, I will write 4 plus h minus f of 4, the whole divided by h. Now I will solve this, but y is equal to x square. But this would be y is equal to x, that f of x plus h minus f of x. F of x plus h minus f of x. Okay, x plus h, that is 4 plus h minus f of 4. But remember, my f of x is nothing but it is x square. So do not forget to square the brackets. So it would be like this. Okay. This is x plus h. And this is x, f of x. So I would say it is limit h tends to 0, 4 plus h the whole square minus 4 square divided by h. So this was your y. Y is equal to x square. So you do not forget to square this. Okay. So now this would be limit h tends to 0, 4 plus h the whole square, it's a square plus 2ab plus b square minus 16 the whole divided by h. So this becomes limit h tends to 0, 4 square is 16. 16 plus 8h plus 8 square minus 16 the whole divided by h plus 16 and minus 16 goes away. So what I am left with, g is equal to limit h tends to 0, 8h plus 8 square the whole over h. So it is limit h tends to 0. I'll remove h as common. So it is 8 plus h over h. So its limit h tends to 0, 8 plus h. So I had to show that g is equal to limit h tends to 0, 8 plus h, and I found it. Okay. Now deduce the value of g. Now I want to find the value of g, the b part. So h is 0, so I'm going to substitute h as 0. So g is equal to h plus 0. So g is equal to 8. With this, I complete example number 2, where I'm differentiating using the first principle, f of x plus h minus f of x, where y is equal to f of x. Okay. If it is x square, do not forget to put the square sign.